This picture that we start with is a sleeve I made with one sensor. And this sensor, when you go like this, it says 1, 2, 3. When you go like this, it says bye-bye. And when you just go like this, these lights, there are four electroluminescent lights. These flash, maybe like flashy part of your clothing. And so the interesting part is that the one sensor can tell between these different gestures and what their value is to other people. I have been working for the last 10 years thinking about how to show that artificial intelligence can be reliable and robust in natural and even dangerous situations. Because actually, what people say, what they fill out in a profile, it is maybe what they want you to understand. What they do, that is much more honest. So I think that the sensors getting a implicit communication from a person is going to be a much more reliable indicator of what they do and what they want to do. Also, it is not so distracting. These early systems I built, I made this bed that maybe is going to tell you that you have stopped breathing, or for me, I had an arm, and this arm had a problem because this ligament was always damaged for 10 years. And I thought maybe physical therapy, they were going to do this, they were going to do that. It turns out I was sleeping on it. And because I was sleeping on it, it did not get enough profusion to heal. When I stopped sleeping on it, then my arm fixed, and then I could go rock climbing again. I love to go rock climbing. Early on, in late 90s, we made an exercise machine with a computer that used that knew who you were. At that time, we used personal area network. I don't know if you remember this, but it was near field RF to decide how to encourage you to do different exercise today because you did such a good job yesterday, or to lighten up because you've been going down with overuse. In any case, there are so many possibilities when you integrate the sensor in the scenario. And at Media Lab, I have made so many different things across domains to show that they will work in normal settings, even in the automobile, even on a bicycle, and so on. But the idea of virtual sensor is this idea that it is a model of the human and the task and the system. And these being dynamic, you can make the sensor be useful. We will talk about this all day. And so what you probably know me for is this pointing device in the middle of the keyboard. And I thought it was going to be a very simple little project. But what I realize is that this finger, it has a lot of representation in the mind. It is very good to use this for trying to communicate because we have so much experience with a pen. And so we actually, the things that we use it for, after figuring out how to make this a good controlled surface, which I talk about for just a minute, we find that even at Johns Hopkins, we made a pointing device on a laparoscopy tool. And because this thing limits, it recognizes how to get rid of the shakiness in your hand, the doctor was able to control the camera without having a separate person controlling the camera. It was a better way to do surgery. And we find, I'm surprised to find out that the people that are blind, they like this pointing device because actually it is more controllable for them because, well, first of all, it does not slide off the table. Second, they can see it. It does the same thing each time. And people without arms, they like it too. That surprised me. So what was special about this device was not only that it was in the middle of the keyboard. That idea was central because it means you do not have to move your hands when you are typing to make a pointing selection. And that saves almost 1 second every time you are about to make a selection. And that is why the track point in the IBM's computers, it is 25% faster than even a mouse for doing type select. So you don't have to take your hand off the keyboard. But what we found out was that actually, if we have a model of how much a person's fingers shake, and we have a model of how their eyes move, and we have a model of how to speed up and how to slow down to make the people more accurate, we could improve performance of selection by 25%. And these kind of selections, improvements, this cognitive model, we did not come to this by just reading literature. We came to it by having some background and experience in cognitive science. Then we have idea. One idea we had was maybe if you're going in this direction, you should keep going in this direction. This is, maybe there's even patents from somebody on this. Well, it makes it worse because we call it momentum. It reduces your control because you have to wait and then stop and then come back. It's the inertia. So we found ourselves making negative inertia. And this picture at the bottom shows that kind of a picture of how I feel about it. That when you start pushing, we make it go faster than you want. That's the green line. And when you try to stop, we make it slow down faster than it should, than you are showing with your finger, because we have a model of what speeding up and slowing down is, and that alone made a 15% improvement in the slowing down and speeding up. Enough of this. I'm just saying that this idea of a cognitive model can be helpful. And so it's what we do that says so much. And this picture here of Andrea Lockhart, she is looking at a dog. And if she stares at this dog, and if she blinks nervously, because when you are giving a speech, you blink more fast, then it goes, and then if she looks away, then it is relaxed, because there's no confrontation. But what is interesting is I've done many, many different kinds of eye tracking systems. In this case, we don't have camera. We have one photodiode and an infrared light. Because actually, I can tell if you're blinking quickly just by watching that the reflection goes away. I can tell you fell asleep just by the reflection goes away. I can see a wink by how long your eye is closed. I can tell if you are staring because the color of your eye, it does not change the intensity of the reflection off your eye if it is stationary. And so we can tell so much from one sensor, and this is what I will say again and again. And just to give you a counterexample, about too many sensors can be worse than too few. This is Andrea Lockhart again, and what she did is she has a, excuse me, I like to point. Okay. She has a camcorder. She is holding this camcorder, and she goes all over Harvard Square, taking pictures of everything. And after 1 hour, we take the signal, and on her wrist there is galvanic skin response, because the sweat and when you get excited, then the galvanic skin response goes up. And we thought, okay, maybe we can find out what she likes to take pictures of by looking at galvanic skin response. Well, let me say this. You spend so much of your life communicating with other people.